Quantum Supremacy, the race to break the internet. There is a hidden technological race happening right now, and it isn't fought with missiles or tanks, it is fought with subatomic particles. Behind the screens we use every day, the United States and China are racing toward a machine that could redefine computing forever. Because one day, the encryption protecting your passwords, financial systems, satellite communications, and even classified networks could become obsolete. The weapon isn't a weapon, it's a quantum computer. For decades, modern security has depended on mathematical problems that conventional computers would take an absurd amount of time to solve. But quantum computing could change that equation. China has poured billions into quantum research, building laboratories, processors, and communication networks designed to push the technology beyond classical computing. The United States is answering with something just as important: engineering. American technology companies, universities, and government laboratories are developing increasingly sophisticated quantum processors while simultaneously building a new generation of encryption designed to survive the quantum era. It's called Post-Quantum Cryptography, and the race is happening on two fronts: build the machine that could break today's cryptography, and build the cryptography that survives that machine. But what makes quantum computers so different? The answer is the qubit. A classical computer stores information as bits, 0 or 1. A qubit can exist in a quantum superposition of 0 and 1. Add more qubits, and the mathematical space they can represent grows exponentially. This doesn't mean a quantum computer simply tries every answer simultaneously. It's more powerful and more complicated than that. Quantum algorithms use superposition, entanglement, and interference to amplify useful solutions and suppress the wrong ones. For certain problems, calculations that could overwhelm classical machines may become dramatically faster. And there is another engineering nightmare: temperature. Many leading quantum processors must operate only fractions of a degree above absolute zero. That means American engineers aren't just programming computers. They're building machines that operate at the edge of physics itself. But quantum supremacy isn't guaranteed. Qubits are fragile. Errors accumulate. Scaling the technology is brutally difficult, and nobody knows exactly when, or if, large-scale fault-tolerant quantum computers will arrive. That's why the cryptographic race has already begun. Organizations around the world are replacing vulnerable algorithms before quantum machines become powerful enough to threaten them. The countdown isn't necessarily to a single breakthrough. It's to an entire technological transition. Because the first nation to master practical quantum computing could gain an extraordinary advantage in science, medicine, artificial intelligence, logistics, cybersecurity, and materials engineering. The United States has the research ecosystem. China has enormous investment and scale, and both are pushing relentlessly toward the same horizon. The future may not belong to the country with the fastest classical computer. It may belong to whoever learns to control quantum information, because the nation that masters quantum computing doesn't just win a technology race. It could help define the operating system of the 21st century.